So it's time for another super fun, exciting math lesson. So this time, you guys know how to find all three methods to find the zeros of a quadratic function. So now it's just kind of playing around with it and going a little bit deeper into finding out a couple things. So zeros of a quadratic function. The solutions to a quadratic equation are often called the x roots. So you guys already know that. Okay. Or another word for that would be the zeros. So we can say the solutions, the zeros, the x roots. And we even saw that in class yesterday when we were calling it zeros and roots and solutions. All three. So in order to find the roots, the quadratic equation must be expressed in standard form. So we want to make sure that it's an ax squared plus bx plus c, and it must be equal to 0 before it can be solved. So just like yesterday, if your equation wasn't equal to 0, then you could not solve it. Recall that quadratic equations can be solved by either factoring or completing the square, and it can actually even be done by using the quadratic roots formula, but we'll get to that. So we're going to solve the following quadratic equations, and the first one maybe we'll factor, and the second one we'll use completing the square. So in example 1a, I noticed that my equation is not equal to 0. So I have to make sure that that's the first step that I do, so I'm going to subtract 6 on both sides. So I'm left with a new equation of x squared minus x minus 6. You can't actually do anything from here, but now it's in standard form where your equation is equal to 0. So to factor this, we need two numbers that multiply to -6, but add up to -1. I know that -3 and 2 will fulfill these conditions. So if you have x minus 3 and then x plus 2, if you just want to double check that, you can expand. -3 times 2 is -6. -3 plus 2 is -1. So I know that I factored this properly. Now we're going to split them up. Okay, split this up and make each factor equal to 0. So in this case, instead of we're going to find x, we're going to add 3 on each side, which makes x1 equal to 3. And for this one, we have x plus 2 equals 0, which makes x equal to -2, and that's actually x2. So I'd like to see x1 and x2 so that you see that there are two solutions. So in this case here, when it says solve, it means to find the roots or the zeros or the solutions. So at the end, I'm just going to put the roots, just because it's a shorter word, are 3, 0 and -2, 0. Okay. And that's your full solution. And this is using factoring. So I'll just go ahead and write that right up here. So solve using your factoring method. So now I won't necessarily say find the zeros or find the roots. It's going to actually just say the word solve, and you need to know what that means. Okay. So I'm just going to highlight that word here so that it's a bit more clear. All right, moving on to the second one. First thing that I notice is that this equation is not equal to 0. So I'm going to go ahead and subtract 6x on both sides. And while I'm doing that, I'm going to put it in order. So I'm going to put the minus 6x right after the x squared because that's standard form. It's ax squared plus bx and then plus c. So in this case, finding two numbers that add up to 4, or sorry, multiply to 4, the only factors of 4 are 1, 4, and 2 and 2. And none of those numbers actually work to add up to -6. So factoring is out. You can use the quadratic roots formula, but just for the sake of this, we're going to do completing the square. Okay. So to complete the square, we have a value of 1, so we don't need to divide the first two terms by anything. We're going to take the middle value. We're going to divide it by 2, which gives us -3. And when you square that, it gives you +9. So you go x squared minus 6x plus 9 minus 9. And again, I like to put all of this in a bracket, plus 4, just so that it's the same process the entire time. So from here, you're factoring the first three terms, and remember that the answer is always the one before you square. So we have x minus 3 squared. You can just take out the negative 9 because there's a 1 in front of this bracket. And 1 times negative 9 is negative 9. So if I keep going here, I have x minus 3 squared minus 5. So I just evaluated negative 9 plus 4. At this point, I need to solve. So you need to use opposite operations. So basically, I'm going to get rid of anything that's further away. So this minus 5 is going to be canceled out by doing plus 5. And 0 plus 5 is 5. I'm going to get rid of the square root. The square, sorry. To get rid of the square, I do the square root. When I do the square root of 5, I don't want an actual answer. I'm just going to move this over and rewrite it just so that you can see what I'm doing here. Okay, when you do the square root of 5, it's either a plus or a minus of an answer. So in this case, we're going to change this to plus or minus, but instead of calculating root of 5, we're going to leave it as root of 5. So that gets rid of the square root. So we're left with x plus 3. I left it in brackets, but it's not really necessary because it's a positive. And now we're going to subtract 3. So x equals positive or minus 5 and minus 3. Okay? I think I made a mistake here. Hold on here. It's x minus 3. I just copied it wrong. Sorry. So it's x minus 3, which changes a few things here. So that should be x minus 3, and to get rid of a negative, you have to add 3. There, that's better. Now, this just looks funny, so I would rewrite this as 3 plus or minus square root of 5. It's just the way you write radicals. If you have a constant, you write it first. So those are the x roots, and that's how you solve any quadratic equation. You can use completing the square or factor. So let's just do a therefore. This time I'll use the solutions are x1 equals 3 plus root of 5 and x2 equals 3 minus root of 5. And that's what I'm looking for, this sentence right here. But remember, you don't need to use the word solutions. You can go with roots or zeros. Okay, by completing the square to solve for the general equation, quadratic equation, we can develop the quadratic formula. So this part here, when you take the quadratic formula, it comes from the completing the square process. So you would basically divide the first two terms by the a, and then you would go on to dividing the middle term by 2 and squaring it. It's quite the process to do, but if you'd like to try it, take your original formula. So I'll just write that down on the side. Take this formula right here, plus bx plus c. Take this formula and use completing the square to develop the general equation for the quadratic formula. And if you do that, I'll give you guys bonus marks. You don't have to do this, so don't feel like you have to. And I'm not helping if you are attempting it because it is a bonus mark. But again, take this standard equation, the standard quadratic equation, and use completing the square, and that will give you at the end negative b plus or minus square root of b squared minus 4ac divided by 2a. So this formula didn't just come out of nowhere. Someone derived it from completing the square. So if you want to give it a try, a few bonus marks there. Might take you a little bit of time, but it's pretty fun. You can hand that in to me tomorrow and I'll give you some bonus marks. So let's verify the quadratic formula using x squared plus 4 equals 6x. Remember that you can't solve if your equation is not equal to 0. So we're just going to subtract 6x on both sides. I think this is the same equation that we just did. Just going to go take a look real quick. Yeah. Okay, we're going to sub in some values here. So we have a equals 1, b equals negative 6, and c equals 4. So when we use the formula, we'll have negative 6, b equals negative 6 plus or minus square root of negative 6 squared minus 4 times 1 times 4, and all that divided by 2 times 1. So we just have to simplify a lot of this. Negative times a negative, it's a positive. Remember that negative 6 squared is positive 36. 4 times 1 is 4. 4 times 4 is 16. There's only one negative, so the answer becomes negative. 2 times 1 is 2. Moving on. 36 minus 16. I know you guys might be laughing that I'm using a calculator, but I want to make sure I get it right. All right. Square root of 20. Divide that by 2. You can simplify your radical. So we know that the radical can be changed, instead of root of 20, we can change it to 4 times 5, which is 2 root 5 divided by 2. All three numbers on the left, the right, and the bottom can be divided by 2. So we're just simplifying that. I'm going to have to bring this over to this side. So x equals 3 plus or minus root of 5, because 2 divided by 2 is 1, and on your denominator it's 2 divided by 2 as well. So you've got two roots here. If we double check, it's the exact same thing as the one above, in which it should be. So whether you decide to use the quadratic roots formula or you decide to complete the square, it should be the same solutions. Okay, so we use the word solutions, we use the word roots. So I'm just going to go ahead and say, therefore, I'll use a different one there. The zeros are x1 equals 3 plus root of 5, and x2 equals 3 minus root of 5. So that's just to show you that whether you use the quadratic formula or not, it always will give you the same thing. So the quadratic equation in standard form has real roots that correspond to the zeros of the function f at x. So it's just in function form. Don't let that confuse you. F at x can easily be replaced with a y or a 0 if you're solving. So if you are solving, you can't put it equal to y because that wouldn't make sense. Finding the zeros means you're actually finding the x-intercept, which means the y value is 0. A quadratic function has either 2 real roots, 1 real root, or no real roots. Okay? So in this case, if we go with 2 real roots, if you've got a parabola that's it is upwards. There's 2 solutions here, right where it touches the x-axis, because those are the x-intercepts. If the parabola is open downwards, it's not the same. So I'll just make a parabola that opens downwards here. Whoops. Okay. And that parabola that's open downwards also has 2 solutions. Okay. So a parabola only has 2 solutions, 1 or 0. For one solution, the parabola kind of just like sits on the axis, the x-axis. Okay. If it's open downwards, then again, it just kind of sits on that x-axis, and the root is right here, right at the top. So it's basically the vertex in this case. And then no solutions would mean that the parabola doesn't touch the x-axis at all. So no matter where it is, it will never touch. So that means there's no roots. So the first example was 2 solutions. The middle one is 1, and the last one is 0. So it's easy to tell from a graph. However, it's a little bit harder to tell, let's say it's in vertex form. So they'll have 2 zeros if A and K have different signs. Just a little bit of memory here. So if A and K have different signs, there'll be 1 0 if K equals to 0. So if there's nothing at the end here. And there'll be no zeros if A and K have the same sign. So instead of having to solve every single time, this is a faster way of knowing. Make sure that it's in vertex form though. To get in vertex form, you could